Hello everybody and welcome to the project for Unit 2. So you've sat through the videos, you've dealt with all my semi-boring lectures, and now we actually get to apply that knowledge. So this is going to be the fun part. I'm excited for this, and hopefully this will really help you guys cement some of those concepts that we've been talking about. So we're going to do a supervised learning project in Python, where we are going to compare and contrast three different models at a multi-class classification problem. So this is textbook supervised learning. It's what we've talked about in a variety of the different videos. We are going to use a linear regression model, a k-nearest neighbors model, and then as a support vector machine. So we're going to see which one performs the best, and we're going to do that via cross-validation. And this is going to help us get started actually using machine learning in programming applications. So for this project, I am going to be using Python via the Anaconda distribution. So Anaconda is a great open source distribution of Python, as well as R, but we are not going to use that today. And it's great for data processing, predictive analytics, but more importantly, Anaconda comes with Conda, which is a package and environment manager. And so Conda is going to allow us to download and install all of the necessary packages that we need quickly. Anaconda also comes with Jupyter. So Jupyter is a open source software that allows for collaborative notebooks that you can share code across platform and to other users. So Jupyter is going to allow me to create a project that I can ultimately share with you guys, so you can go back and look at what we have made after this. So I already have Anaconda installed. You guys don't have to use Anaconda. You don't even have to use Jupyter. You could use any Python IDE that you want, or even just the command line. But for the ease of following along with me, this is what I'm going to be using. So let's get started. I'm going to open up the command prompt. And when you download Anaconda, it's important to add Conda to the path, as well as Jupyter Notebook to the path, because then we don't have to actually find the scripts through the command prompt, and we can access them from anywhere. So I have a nice little folder called tutorial where I'm going to start this, and I already have these packages installed, but installing packages with Conda is as simple as typing Conda install. For example, we're going to use NumPy, but we'll talk about that in a sec. For now, I'm going to open up a Jupyter Notebook, and we'll let this go. So we're going to use a couple different libraries in this project. We're going to use NumPy, which I mentioned, SciPy, Matplotlib, Pandas, and the scikit-learn package. So I'm actually going to delete this guy, and we're going to start fresh. So let me open up a new notebook here, and depending on if you've used Anaconda before, you might have other kernels open, but just the Python default should be good to go. As well as you can download Anaconda with a variety of different Python versions. I'm using Python 2.7, and we can check that by just doing a simple import sys, and then we're going to do print sys.version, and this spits out 2.7, 2.713, because that's what I'm using. 2.7 is probably the most common Python version to use for machine learning applications. So even though 3.6 even or 3.5 are out there, 2.7 honestly still comes up more frequently. So we mentioned that we are going to need other packages. Let's just import those now. So I'm just going to do these all at once. Unfortunately, since this is a video, I don't think you're going to be able to copy and paste this information. However, I am planning on sharing this notebook with you guys, so you might have access to it via the course structure. I keep forgetting my import statement. Okay, so those are our import statements, and I'm going to copy this because I can. I have this over here. These are just going to be generic print statements to show what we did up here before, the versions that we were using, and that way we can make sure we are all on the same page. So let's go ahead and run this cell. In Jupyter Notebook, you can run a cell by just clicking Shift Enter. So that's what I'm going to do here, and it is going to import all of those different packages. And that is going to work for a second because there is a lot of packages. And hopefully at the end we're all good to go, and yes we are. So here you see the version for each package printed out, and this is looking good. This is what we should use, Python 2.7, and these are the most current versions of these packages. To download those, let me show you how that would work. If you don't have one of those packages, as soon as you have Anaconda, installing these is as simple as Anaconda install, and we'll just do NumPy, click enter, and it'll run. So this is going to eventually tell me that I already have this package installed, as we have seen in the Jupyter Notebook. However, if you didn't have it installed, it would check the online repositories for the package, find the most current version, and install it to your local Anaconda environment. So, yep, it's telling me I already have it installed, and that's good. But if you are having trouble with the libraries, this is why I recommend Conda. It is very easy to install what you need. So let's move on. In this cell, we're going to import the actual modules, functions, and objects that we are going to use in this tutorial. So we're going to use some different plotting packages, and as well as the sklearn, the scikit-learn. This is the main machine learning library. We're going to import a couple of different both reporting and accuracy techniques, as well as the specific models that we're going to be using. So this logistic regression, this is just a version of linear regression, a linear regression model that we've talked about in the linear methods for regression, and as well as this model actually comes up in the linear methods for classification. Again, we just switch it over to a class designation. And the k-neighbors and the support vector classifier, we've talked about both of those. So let's import these. But we will actually explore the structure of these algorithms a little bit later. So for this project, we are going to be using the iris flowers data set, which contains 150 observations of iris flowers. And there are 4 columns of measurements and the species of flower observed. So this is a very common database to use for these projects because it is kind of a standard in statistics and machine learning. So this data set can be loaded directly from the UCI machine learning repository using this URL. And so again, if you do have access to this Jupyter Notebook, you could copy that in. However, you might just have to type that out. So here, let's add names to our columns when we're importing them so that we can actually keep our values and columns separate here. So this is going to have a couple things, dimensions of the flowers, such as petal length. And again, it's 4 columns, 150 different data points. And finally, the class, which is just going to be the species of the flower. And we're going to use pandas to actually read this and help us import this data. So let's try that. Shift enter, make sure everything goes well. And yes, as soon as this goes from the asterisk to a number, we know that it's completed. There shouldn't be any output for this cell, so that's okay. But let's take a look at some of these actual data set properties. So going in, we can understand the shape of the data, the characteristics of the data, so that we have a better understanding of the problem that we're trying to solve. So let's just take a quick look at the shape, and to do that we're just going to type print, and this data set is a variable now, so we can just type shape. So we have 150 different rows, so 150 different data points, and 5 columns. So let's take a look at those actual columns so we understand what they're showing us. And we're going to take a look at the first 20 rows. So here those are. So here you see this is just an ID for the data point, and then we have the length, width, and then the class. So this is the species of this particular flower. There are 3 species in this data set that we're going to be exploring. Let's see if we can describe those a little bit. So we're going to do dataset.describe, and here we go. So this is giving us some output information again. 150 data points. Here's the mean value for each one, mins, maxes, that type of thing. This is important to understand. Maybe we can take a look at the distribution of the data. Distribution. And the distribution of the classes specifically is what I want to know. So dataset.group by, I'm going to do the class here, and then we can take a look at the size of those groups. Aha, so here's our 3 species, and we have 50 of each. So pretty evenly divided, 50, 50, 50, about as even as it could be, in fact, for 3 classes. So not that big of a data set, and that's why it's pretty easy to load and visualize here. And to get an even better understanding of this data, we're going to do some data visualizations. Now, it might seem unnecessary to take this extreme of a look at the data going in. However, remember, different types of distributions are going to perform better with different algorithms. So we really want to know as much about the data as we can so that we can make those inductive bias is as accurate as we can right from the start. If we know more about the data, we can pick a model that is better fit to the data. And so that is the motivation behind doing these. So let's look at some histograms. Dataset.hist, and Python, very easy. Most of the syntax and vernacular is pretty intuitive. And this PLT, up above we imported matplotlib as PLT from matplotlib as PLT, so we're using that PLT designation. And so this is going to load, and boom, here is the distribution of our data points. So on these bottom ones, it looks like we have a Gaussian distribution to a couple of our different data points, and this is good because a couple of our algorithms are Gaussian based, so hopefully those will fit well to this. Let's do a scatter plot matrix. These are always fun to look at. Scatter matrix data set, and then PLT again, show. And this will help us understand the relationship between some of the variables. Very nice. So you see here how some of these have a linear relationship, which is good because it means there's pretty strong relationships between a couple of our variables. So petal width and petal length are interrelated. They're dependent on each other. And again, you see that linear nature in some of these other ones up here too. And that relationship between variables is going to help our machine learning algorithms actually perform better. If everything is independent, we have a much harder time actually building accurate algorithms. So let's actually get into the machine learning part. We've taken a look at the data. We know some of it has a Gaussian distribution. There's strong dependence between the variables. We think that this could be a good problem to solve with linear methods as well as some nonlinear methods, which would be our k-nearest neighbors, and the SVM actually here is going to use a kernel, so it is going to be nonlinear as well. But once we actually load those algorithms, we can explore their structure a little bit more. But first, what we actually have to do is curate our data set a little bit. So we want to create a validation data set. We want to set up cross-validation, and then we can actually get into building the best models. So to create a validation data set, we're going to split the loaded data set into 2. So 80% of the data we will use for training, and then we're going to save 20% of it for that cross-validation, because remember back to our videos, it's not how well the algorithm performs on the training data that's important, it's how well it can predict new instances or generalize to new data points. So let's do that. Now we're going to split out this validation data set.